Everybody, it's Tyler here at the Lakeshore Qualifier event in Wisconsin, checking in team number 1732, Hilltopper Robotics, coming out of Milwaukee. And today I'm here with Miles and Owen. We're going through this brand new 2021 robot they created this year. Of course, following that power cell journey through their intake, all the way into their shooter. Cool climber as well. And the first time this team has done swerve here, all coming up on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. If your team or organization is hosting an off-season event, did you know you can stream it right here on FIRST Updates Now for free? Events that stream on FIRST Updates Now receive an additional 25 to 100% additional viewership because we help you promote your event on a large platform. If you're interested, reach out to us on any of our social platforms, on Discord, or send us an email at admin@firstupdatesnow.com. Let's get your off-season event streaming on FIRST Updates Now. Hurry, dates are booking fast, and we take first come, first serve for all our events.
So starting on this robot, as mentioned, first year you guys doing Swerve. So talk to me just a little about that experience, what you've learned from Swerve, and especially for teams who are looking at getting into Swerve, what you might tell them as well.
Yeah, so we chose to go with a Swerve module that other teams have used before to kind of eliminate some of the troubleshooting issues
which one
we
is
might
that?
have. ThriftyBot, I believe.
Yeah,
right?
from ThriftyBot. Yeah,
Yep.
Great module. Yep.
And we decided to go with the brand new Talons. Just allows us to kind of simplify the whole electrical board and everything. Difficulties we've had is keeping those wheels aligned and getting the encoder values to stay how we like them.
So if you had to tell like a new team coming in, what's like the one thing you say, hey, this is something that we really learned that you guys should try to avoid?
So yeah, make sure that you have, make sure you know your encoder values and always have them reset, because we have to turn our robot off to reset all of our encoder values. So make sure you know when they reset and where they reset to, because they might snap to a different position at the start of the match that you don't want. So just make sure you always know what your encoders are reading and where your wheels will start at the start of the match, or else you could get completely messed up.
Makes a lot of sense. So let's start out on this robot here with the intake. Talk to me a little about some of the premise behind it. Obviously, a lot of Mecanum wheels, but just talk to me about some of the build construction and anything you might have changed over the time.
Yeah, so with this robot, we decided to go with no pneumatics at all. So for our release mechanism, we have a latch, and when we power the intake, it actually releases it. So as you can see there, we have Mecanum wheels that center the balls in, and as it comes through our three roller intake, it leads us into our ball centering mechanism.
So during a match, do you typically leave it deployed the whole time, or you bring it back up during the match?
So we can't actually retract it on our own. We have gas springs that put pressure forward, but there's nothing that allows us to retract the intake in the match.
So during your build, how did you take that into consideration that, you might have robots potentially hitting your intake, that sort of thing?
We wanted to make sure it was rigid enough that it wouldn't break, or it was flexible enough that it wouldn't break when it was hit, but it was rigid enough that it wouldn't cause us too many issues. So we decided to go with 15-pound gas springs, so that keeps the ball, or that keeps the intake down, and we don't have any issues with height when it's intaking the balls.
Makes sense on that. So next up is just we have some Omni Wheels that are pulling that in. Just talk to me a little about this transfer system between your intake and this indexer here.
Yeah, so as the balls come up through the intake, they hit our centering wheels here, and those centering wheels do a great job at bringing the balls right in the middle, shooting them up into our shooter.
So Owen's next going to be talking about, as it kind of comes into here, and we'll show a power cell coming in here in just a second, but talk to me about this S-curve here into these brushes, and why specifically you chose like these brushes to bring them up as well.
Yeah, so as you can see, we have the shooter shooting the opposite direction as the intake. So we can back up, grab some balls, go forward without turning anything, and then stay aligned with the shooter. After the ball comes through these wheels, it is caught by those spinning brushes in the middle. Those spinning brushes can be used to move the balls towards this feeder wheel, which feeds the ball to the shooter, or those brushes can also be used if we have a ball jam to bring the balls back in the train and unclog the system if we either grab too many or accidentally get one stuck in this wheel or in the intake. So that is a very nice addition because it keeps the track clear, and if we did have a failure like that, that could kind of end the entire match. We chose those brushes because they are rigid enough, cut similar to the intake, but they're also flexible, so we're not getting caught. It's not like a plate, where a plate could also get caught in the system if we had two balls and it pressed the ball, like put pressure on a ball weird or gets caught in there. So the brushes they don't get caught themselves, but they can help move it out while you helping with this.
So taking me next into this shooter here, I'm very curious to learn more about. Obviously, we have a few, looks like almost worn down Coulson wheels on this. And then I'm interested in these gears that you're using as well, too. Are these essentially additional weight for your flywheels, or how does that work?
Yes. So these gears out here are additional weight because these wheels were Coulson wheels. And what we did was we took them on the lathe and we shaved them down.
Sure, all right.
So we lost some weight there and they aren't very heavy. So yeah, we kept the weight on there. So we had some. So we don't need to wait in between shots. It keeps up speed pretty well. Normally, if there wasn't as much weight there, we would have to wait, get up to speed again, and shoot again. So we can take those nice successive shots because of that extra weight.
Is the rollers or the wheels that are here, are these also being driven? Because I would think that'd help out with that as well.
Yeah, so those are feeder wheels.
Sure.
What that does is once the brushes bring the ball up to the top, it waits there. Once the shooter's up to speed, after we've turned it off, this spins, pushes it into the shooter wheel, and then it shoots, and it holds the next ball until necessary, and you go again, and then you shoot.
A couple last things on this robot I want to talk about is your climber here, multi-stage climber. So talk to me a little about how this deploys. We'll show it deploying as well, too, and then just how it ends up hooking on. Is this actually coming off like on a winch, or how does that work?
Yeah, so down here, we have a Neo 550 going to a gearbox with some gearing up because we need a lot of torque in order for that small motor to fit in there and take this climber. So it is just a winch. There's no ratchet, but we do have a hard lock on there, which is a little loop of string that hooks into the spool. So there's a little spool in the hook so that mid-match, it won't just come out because those motors aren't perfect. They do have a brake mode, but this will still slowly go up because of these springs that are used to bring the stages up. So that hard stop holds it until we're ready at the end game such that we can climb. And yeah.
So two last things on this robot I want to ask you about. We can talk a little about your CAN bus and how that works. And lastly, I want to ask you about, this is probably one of the smallest robots I've seen this year, maybe a couple others that can match it. So talk to me about the frame size and the weight as well.
Yeah, so I'll start with the CAN bus and I'll hand it off to Miles to talk about frame and weight. But essentially this year, because we're using all these Spark Maxes, because we have so many Neo motors with all the swerve modules, what we did was a 5-star design instead of the traditional series. That prevents the CAN bus from breaking out. It's like putting your wires in parallel instead of in series. So if one of the CAN things breaks, it will not break the entire chain as normally would happen. Instead, it'll just kind of pull itself out of the chain and everything else will still work because it's in that parallel structure. So we use 5 wide Wago lever nuts so that all those wires can come to one central place and get that signal. So if something breaks, everything still works. And it's consolidated space and complexity of the internal wiring, which is very helpful for electrical.
Awesome. We'll wrap us up on the framing and the weight of this robot and kind of why you chose to go that route too.
Yeah, so we decided to go with a small, light robot this year so we can be nice and nimble and maneuverable, specifically for the skills challenges.
Sure.
That maneuverability will allow us to better complete the challenges in a faster time. It also was a good design exercise for the team, trying to work around different obstacles that you might not encounter. One of those obviously being there's no room for pneumatics, and that's why we had to come up with the interesting intake release solution.
And what is the weight on this robot?
It's between 70 and 80 without the battery.
Sure, makes a lot of sense. Well, 1732 Hilltoppers, thanks for taking the time to tell us about your robot here. Of course, good luck qualifying, hopefully, for the Wisconsin Championship. And can't wait to see your team in future competitions and future seasons as well. Thanks for taking the time.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FRC alumni to join their internship program, and FRC mentors who are looking for a great career with a company who actually supports their FRC journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.